In this example, again, I'm looking for something that is the innermost part of my function. So I say, okay, well, I've got that, there's an x squared out front, but I see this, there's like sort of this outer innermost thing, that x cubed plus one, that's inside of a square root. So our u then is going to be the thing inside of that square root. So x cubed plus one. Here comes Mel. I told you. Now we want to differentiate that thing. So what is the derivative of x cubed plus 1, Maleficent? You should know this by now. It is, no, it's not that. It's, yeah, that sounds better. It's 3x squared dx. Now this one we run into a little bit of trouble. This stuff that's left over, this dx and the x squared, that's some of what we have, but we also have a 3 there, and we want to bring this du into there. So let's get rid of the 3 so that it matches what's in our integral. So we'll divide this by 3. So du over 3 equals x squared dx. I like that because that matches these two pieces. So I can replace those two brown pieces with just a du over 3. Now it's a little messy there, right? Yeah, just a little bit messy, but that's a little bit better than seeing an x squared dx. I'd take a du over 3 over an x squared dx. Then also we've got our square root. Inside of the square root, we have just a u now because we're replacing that x cubed plus 1. And then we keep everything else. So this is the antiderivative of the square root of u multiplied by du over 3. We're not worried about differentiating that thing in this problem. We're just making sure that we can substitute in everything so we don't have any more x's in it. Now, in this example, it's not really clear what is our innermost function. We can tell that there's an outermost function with those squares, but is the innermost part, is that going to be tangent or secant? Not really sure. I do know that whichever one I choose, I'm going to take the derivative of it. And one thing I'm thinking about is the derivative of tangent is secant squared. Ooh. So let's use tangent as our u. So this little tangent thingy here, because then that'll work out to what we have already. So u is the tangent of x. And then we get that part because we're going to do the derivative of it. So that's du equals the derivative of tangent x is secant squared. Oh, I forgot the c. Squared x dx. Which is great because that's what we've got, secant squared x dx. Oh, wow, that's awesome. So when we substitute it back, this secant squared x dx, that is just going to be replaced with a du. How sweet. Then we've also got our u, but, oh, I would like a different color, please. We've got the tangent squared. We know tangent we're going to say is the same as u. We still have the squared, though, so we get, wrong color. Of the squared, and we still have the antiderivative. So there we were able to substitute it, so we only have u's instead of x's, and it's much easier to differentiate u squared than it is tangent squared and secant squared. Oh, look, cat. Let's try to see what happens if we do this with an actual problem. Let's actually do one of these integrations. So I want to figure out what my innermost piece is. Well, my innermost piece is going to be that x squared minus 9. So that'll be my u. I'll do it off to the side here. So my u is x squared minus 9. Ugh. So du is going to be the derivative of that, which is 2x dx. Okay. Oh, great. Look, it's right there. I should do it in a different color. So this is right there. Cool. So we can replace that 2x dx with a du. We have this u here. Wrong color. Colors are important. So we've got this piece that's right here. Awesome. And then we still have the cube. and we've got our antiderivative. Okay, so let's figure out what the indefinite integral of this is. Let's do the antiderivative. So that would be u to the fourth divided by 4, then plus our c value. Now, we wouldn't just stop there. We've got this u thingy. We want to bring back the u that we started with. So replace that u with an x squared minus 9. So inside of this parentheses, we'll put x squared minus 9 over 4 plus our c value. And that would be the indefinite integral. It does say to check by different... Oh, wait. I forgot the 4. Whoop. It does ask us to check by doing the thing. Find the derivative. So if we did the derivative of this purple thing, if we did d over dx, we would drop that 4 in front. So we'd have 4 x squared minus 9 over 4. And then we would have to chain rule that problem because we would do the derivative of the inside. So the c would drop out. I haven't gotten to there yet. Do the derivative of the inside, that's 2x. Our 4's cancel, and oh, look, that sure looks familiar. Haha. So it did work out. Again, the c, we would take the derivative of it, but just be 0. Okay, in this problem, we've got a lot of different things going on, but it's pretty obvious who's innermost. That looks pretty juicy for innermost. So we'll do u is 4x cubed minus 9. And then our derivative of that is going to be 12x to the second dx, because I'm finding the derivative with respect to x. Cool. Aw, dang it. This has got a 6 and this has got a 12. Well, let's just fudge it. If we just want to turn that 12 into a 6, let's just divide by 2. And then zing-zadang, everything's going to match just fine. So we'll have du over 2 equals 6. Now are you gonna call me out for doing that, Mel? It's gonna be fine. So 6x squared will match all of that stuff because that's our goal. We want to try to get our du to match the stuff that we don't substitute. If we've got exponents left over, that's fine. But the stuff that we don't substitute, all that should go bye-bye. It's gonna be fine. I know, we'll bring it back later. Don't be upset about it. So 1 over u cubed, and then that 6x squared dx is going to get replaced with a du over 2. Does that sound good, Mel? U over 2. Okay. So what can we get rid of in order to kind of clean this up? Well, we can bring the 2 out front. That's a good idea. So that's a 1/2 integral. She's biting me. Don't bite me. It's okay to bring out the 1/2. So we get u to the negative third du. Yeah, cool. So let's find our integration, Mel. Here we go. So that is going to be 1/2. She's going to bite me, watch. Or maybe watch the math. I don't know. What are you going to watch? It's so uncertain. What are we going to do? U to the negative 2. Ow! Plus C. Good. I played with her a little bit to get her off my back. All right. So we want to bring the U back. So that is going to be 1/2. We need to convert the U, 4x cubed minus 9. Note that I'm not bringing the 1/2 into the C. I don't need to multiply the C by the 1/2 because if I multiply the C by the 1/2, it's still just a constant. Okay, I would like to clean this up just a little bit, just for like my own benefit. That negative exponent, let's bring that to the denominator. What are we doing? And then also in the denominator, we get the 2 times our negative 2, which will be negative 4. All that jazz. Plus c. We need something in the numerator, so we'll put a 1. And there we go. We do still want to check this to make sure that it works with the stuff. Check it by finding the derivative. So I know I just put it there, but I'm gonna bring it right back. Woohoo! So we get negative 1/4, but at least I can still write it in a nice format for differentiating. Negative 2 plus c. So I drop this thing to do the derivative. So 1/4 of negative 2, that is going to be a half. And then we still keep our 4x cubed minus 9. Now it's going to be to the negative third. Then we need to chain rule this thing. So that'll be 12x squared. And then the derivative of c is just going to be a 0, so that's gone. Now we do want to clean that up a bit just to make sure that it matches with what we started. I am going to, half of 12 is 6. So we get 6x squared over 4x cubed minus 9 to the third. Oh, great. Is that what we started with? 6x squared over 4x cubed minus 9 cubed. Great. Worked out. All right, so TLDR about U substitution. Your goal is to find that innermost composite function, figure out the derivative of it off to the side so you can bring it back. So you just have the function, the kind of like shell around it, and just a U on the inside. We don't have a chain rule for anti-differentiation like we do for regular derivatives. So we want to substitute things in so we're able to find the antiderivative of things. If the first thing that you try to like U substitute, you try to sub it back in so you just have U's, it doesn't quite work out, you might need to do a little work over here with what you've got for du, or maybe just sub in something different. Try something else for your U value and see if that works better. Be careful though, once you are done, that after you do that anti-differentiation, that you bring back that x value so that your answer is still in terms of x or t or whatever you had. All right. Thanks for watching. Goodbye.